In today's video, we will be discussing Physics 251 Week 8, Video Explainer problem number 46. For this problem, we are given the task of finding the tension in two wires in a system where we have a 300-gram mass here rotating around at a constant velocity. Since we're given that the system is moving at a constant speed while it's rotating, we know that this is a uniform circular motion problem. And so if we have any issues with this concept, I recommend going to the Week 8 lecture notes, specifically between pages 17 and 30, in which Professor Yu does a great job at explaining what uniform circular motion is. So getting into the problem here, we have our constants that I've written out here, and we're also given this diagram here. And I've gone ahead and blown this diagram up bigger right here so we can kind of look at some of the forces that are being discussed and try to maybe get at some of the relationships between them. So we have, I think it's important to note that since our tension is at an angle, we have both y and x components of our tension. So it's important to kind of separate those out. Here we have our tensions in the y direction, and here we have our tension in the x direction here. So we also have our radius here. This is our radius for the whole system as it spins, of course. So getting into the problem here, let's go ahead and solve for this theta right here. So this theta is going to be given by these two side angles here, in which we get a theta of 30 degrees. And from here we can use this theta to solve for pretty much all the thetas in the problem. So starting off, we're going to go for the sum of our forces in the x direction. So when we're adding these up, we're using these two relationships that I've written down here because this is our force as it's kind of pointing into the axis of rotation here. So after finding this relationship here, we also need to factor in the centripetal force right here, which is given by this equation. And then after a little bit of algebra, we get that T1 plus T2 equals 22.5 newtons. So from here, we can solve for our forces in the y direction. And we have, of course, our tension force in the y direction, as well as our force due to gravity and our tension force in the positive y direction here. So again, after some algebra, we get that T1 minus T2 equals 5.88 newtons. And from here, we can just kind of add and subtract to get the relationships here. So our tension 1, or tension in the upper wire, is going to be 28.38 newtons, and our tension 2, or our tension in the lower wire, is going to be 16.62 newtons. And if we look at this in the context of our free body diagram here, or excuse me, just our diagram here, we can see that this makes sense, because we have our force due to gravity here. And if we consider that these forces are in the y direction are going to need to even out, we can say that, of course, the tension in the upper wire must be bigger to kind of counteract the force due to gravity. So this does make sense. And I hope you guys enjoyed this video. Thank you for watching.